The idea or concept behind the repeated measure analysis is to show if there is a change, an increase or decrease on some measurement over time. In this case, what we're looking to determine is if students' oral reading rates, or the number of words read correctly per minute, increases from fall, winter to spring terms during their school. And then we can also compare gender within each of those levels. The first part of the analysis, we're just going to do what we call the one within repeated measure analysis. So we'll just be comparing these terms or levels of reading without the gender factor. So we can go to Analyze, General Linear Model, and Repeated Measures. Now, in the factor box, we can rename that. We can call it, in this case, let's call it term. And the number of terms, there's 1, 2, 3. So we'll put 3 in that box, and then we need to add it to this box. And then we need to click on the Define button. Now, what we can do is we can drag the fall term, that's our first level, winter term, and then spring term. And then we want to look at plots, and because we only have one factor, we're going to put term on the horizontal axis. Now remember, we have to add that or it won't show up in the output. And then continue. Now we don't need post hoc tests in this case because we don't have any between subjects factor. But in terms of the options, we're probably going to want the means for each one of the terms. So we want the mean oral reading rate for fall, winter, and spring, and we could compare those main effects. We also want to get the descriptive statistics, the estimates of effect size, the observed power, and we'll also select the homogeneity tests. And then we'll click on Continue and OK. And notice in our output we see the means oral reading rate for fall, winter, and spring. We see the standard deviations, and the number should be consistent across groups unless someone dropped out of the study. So we can see that there is an increase from fall to winter to spring. Then we're going to bypass this part of the report for now, and we're going to look at Mauchly's test of sphericity. And we can see that the term factor, for the term factor, that Mauchly's test is not significant. So what that means is we can come down here and we can read the results for term on the sphericity assumed line. And we can see that our term factor is significant. Our partial eta square is very large, 0.89, and our observed power is 1. And we come down here, and what these pairwise comparisons do for us is they tell us, or they compare the means for term 1 to term 2. So term 1 mean 41.9 compared to 60.063. That's this comparison. And then 41.93 compared to 94.813. So that's this comparison. So what we can see is that term 1, or the fall term, those scores were significantly lower than term 2 and term 3, because we see the significance levels here, and these are starred. But we see that term 3 is significantly higher than term 2, and it's significantly higher than term 1. And so we can see that there's a significant increase in these oral reading rates across the 3 terms or grading periods. Now we'll go back to our analysis, and in addition to doing the one within, now we'll do what's called the one within and then one between. So we'll be comparing the within group, or I should say the within levels, fall, winter, and spring, and then we'll also compare these across these levels by gender. So to do this, we go to Analyze again, General Linear Model, and Repeated Measures. Now we've already really set our within subject factor up, so we don't really need to change anything there. Now if we were to start the analysis over again, yes, we would have to do that. And then we go Define, and we've already defined our levels, but now we want to add gender to the between subjects factor box, and everything here should already be checked. Yeah, we have everything here checked from the last time, except it would be probably a good idea to have gender means displayed, and then the gender by term means displayed, and then continue, and then OK. Now for this part of the output, for this part of the output, it's going to give us a lot of the same information. In other words, we have the means by fall, winter, and spring, but now the means are also divided or disaggregated by gender for each one of those terms. And then we can see that again, the Mauchly's test is not significant, so we can look at, again, the term factor is significant, so there is a significant increase in oral reading rates from fall to winter to spring. But we also see that we have a term by gender interaction effect. Now this is not significant, and what this is really telling us is that gender does not differ at one of the terms but not another term. And then the next important piece of this output is to look at this gender factor. So this test of between subjects tells us if gender is significant, and in this case it is. So what it's telling us is that overall there is a difference between males and females across all 3 grading periods. So if we look here, this is the mean for males, this is the mean for females, and so we can see that females are scoring significantly higher than males across the 3 terms on average or number of words read correctly per minute, or reading rates. And then I forgot to put the graph in, so I can go back and do that. Let me go back to Analyze, General Linear Model, and this is Define, this is OK, and then under Options, no, Continue, under Plots, I'm going to put gender on separate lines and term on the horizontal axis, and then I'll add those, and I'll remove the term variable and go OK. So we've already looked at the report, but now we can see what our output looks like when we graph females and males separately on oral reading rate. You can see that they both increase across the terms from fall to spring at the same rate, but females overall, even though they've increased, on average are significantly higher across the board than males.